Dear fellow scholars, this is our recent work about interpolatory volumetric subdivision. In this video, we will introduce two different subdivision schemes based on Catmull-Clark Volumetric Subdivision. These two methods perform well not only in interpolating but in modeling. Some comparisons and applications will also be given later. Surface subdivision is a basic tool in the field of computer graphics. Compared with subdivision surface, much less work has been done on volumetric subdivision. Bajaj proposed a volumetric extension of Catmull-Clark subdivision and analyzed smoothness property in 2002. Professor Xu found the explicit limit point formula of Catmull-Clark subdivision volumes in his recent work. Our work is based on these two papers. Here we go. The first method in our paper is called pushback method. As shown in the slide, compared with traditional Catmull-Clark scheme, the only difference is that the first Catmull-Clark subdivision operation is replaced by the pushback operation. By doing this, the limit subdivision volumes will interpolate the vertices of the original cultural lattice. Here is the detail of the pushback operation. By adding three different parameters and using the explicit limit point formula proposed by Professor Xu, we can easily compute the position of the egg points, face points, cell points, and corner points. After that, we need to construct the topology of these points according to the given rules. This slide shows the result of the above method. The blue points means the vertices of the original mesh. We can clearly see that the limit subdivision volumes interpolate all the blue points not on the surface but also inside. In our pushback method, we added three parameters to compute the position of the vertices. We can see that different parameters lead to different shapes. It brings flexibility when we model in this way. The second method we want to show is PIA method. Before doing Catmull-Clark volumetric subdivision, we transfer the input mesh to a new one by progressive-iterative approximation. Here shows the iteration of this operation. We have proved that after enough iterations, the limit subdivision solids will interpolate the original mesh well. The idea of PIA is very simple. During each iteration, we just compute the difference between the initial points and their limit points. The only thing we need to do next is to update the position of the initial points. It is the comparison between Catmull-Clark volumetric subdivision and our PIA method, which shows the great geometry interpolation property of our scheme. Not only geometry interpolation, our method is also able to realize material interpolation. Here, different color means different material. Our PIA method can interpolate the material values as the vertices of the input model. Here we show the comparisons between our method and the pushback method. We can see that the results of PIA method are more smooth, while pushback method are more flexible because of its variable parameters. Finally, because the result of our method is very easy for imposing the Dirichlet boundary conditions and has multi-resolution property, it is very suitable for isogeometric analysis. Here are some examples of linear elasticity simulation and convection simulation by IGA on our result model. These examples show the great potential of our method in the field of IGA. That's all. Thanks for your watching.